Hello, my name is Mikhail Tikhomirov, and I will tell about a combined approach to hypernym detection for Thesaurus enrichment. This task about they extend the existing thesaurus for some specific domain. Taxonomies or thesaurus are graph structures which organize terms in some semantic hierarchy. Hypernyms is a relation. For example, cat is an animal, banana is a fruit, Microsoft is a company. And the goal of this task is to extend the existing taxonomy with relations of previously unseen words. Specifically for this task, we need to return 10 ranked candidates for unknown words from thesaurus, words from the data, and candidates from the thesaurus. This plan of my talk, okay, and the thesaurus. This task used RuWordNet thesaurus, which was published earlier, several years earlier, and the task is to extend this version with some new words, which are from the extended version, which is not published yet. In this task, for each unknown word, only direct hit to hypernym or hit to hypernym of hypernym can be considered as a correct answer. In this task also contains only nouns and verbs. 7,000 nouns and 2,000 verbs in public set, and 1,500 nouns and 350 verbs in private set. Also, provided us the training dataset, which contains of 8 millions of news articles from 2017. And extended version of RuWordNet was built on this collection, and mainly all new words from public and private sets occurred at least 50 times in this dataset. But in this task, use of this dataset was optional. But the goal of our work was to extract maximum information from this corpus, because it's very similar to the real situation when you have some thesaurus, you have some new domain, and you want to extend your thesaurus for new domain, specific domain, for example. Our method comprised from the several steps, several components. distributional vector representation, word embeddings, some linguistic patterns, specific processing of named entities context. I will tell more specific in the next slides. And the use of BERT in supervised manner to increase weights for candidates. We trained embeddings on News 2070, but we used not WordVec or fast text, but PPMI plus SVD method, because firstly in many not many, in some works, it was shown that this method have comparable quality with WordVec. And in our experiments, this approach shows the better results than use of WordVec. Or yes, use of WordVec. And to do this, we calculate the co-occurrences matrix for the words in the dataset, in the corpus. Then we recalculated scores for every word using the positive pointwise motional information, PPMI. Then we decrease the dimension of matrix by using the SVD method, and then we have vectors for every word which occurrence more than 50 times in the dataset. After pre-processing, of course, morphology analyzer, and then not then, and when processing the corpus, when we see some phrases which exist in the RuWordNet Thesaurus, this multi-word expression were merged in unique tokens. For example, risgoing. In several works was shown that the named entity context can distort the context of the simple words which are not named entity. For example, Mistral is a strong cold northwesterly wind in the northern Mediterranean. But in news articles, often this word means the class of some French helicopter carriers. And of course, when we construct any of word embeddings, this context can confuse the model. And for handle this situation, we did the next pre-processing procedure. If a word occurrence in capitalizes way, we add some prefix. For example, for Mistral, we can add some underlined before. And after this, word2vec or ppmi plus vd will think that it is different words and will count different vectors for these words. Other feature in which was considered in our work is patterns. All our patterns were automatically extracted using some regular expression with which was manually developed earlier, and these patterns was used on News 2070 corpus. We calculated two types of patterns. It's Hypernym patterns, which means, for example, peon and rows and something similar, which can be considered as synonyms or co-synonyms or co-components. And for example, these patterns x comma w comma y, where x is target word, y is candidate word, and w is any other word, and y and x and y and other. Other pattern was synonym hypernym patterns, whose need to increase weight of hypernym hypothesis if this pattern was hit, and also we add direct synset to our pool of candidates if this direct synset was in some synonym hypernym pattern. Okay. Also, we tried to use BERT as classificator. The task was the binary classification task, and we tried to predict if word 2 is a hypernym of word 1. And we trained it on training data was created from RuWordNet, and for each positive example, we tried to add 3 negative examples. Negative example was built from hypernym of hypernym, or hyponym, or co-hyponym, or random synset from RuWordNet. The total trained dataset consists of 1.5 million examples. And after training procedure, for example, if we give the model such sentence as KLS token, agnostic separate token, follower separate token, then BERT predicts that with 0.99 probability, the follower is the hypernym of agnostic. The follower agnostic doesn't exist in the current version or in of RuWordNet. Agnostic follower exists, of course. And the total algorithm you can see the total algorithm in this slide. On first step, for all target words, we get top 100 candidates using the distributional model, and only top 100 candidates which also exist in the current version of Thesaurus. And for each candidate work, we calculate co-hyponym patterns, and if patterns are exist and calculated previously, of course, then the weight of similarity are increased. Is increased, and then after that, for each candidate work or synsets, there if all direct synsets and their hypernyms and second-level hypernyms are retrieved, and only those synsets who direct synsets who also present in synset hypernym patterns remains. Other direct hits was removed from this candidate pool. After step 3, we have pool of synsets with some statistics and features about patterns, causing similarity, number of times we number of times this synsets occurs from top 100 candidates, because, for example, we can extract some synset several times. For example, if we hit to hyponym and hyponym of hyponym, because after that we add 2 times this synset. And after that, for each synset candidate, we calculate the BERT predictions and probabilities. Result formulas can be seen on this slide. Score base is related to to steps 1, 3, and calculating a synonym hypernym pattern 2. Because if and 3, because when we add second level hypernym, we also decrease the weight of this situation. Also, we try to count the count of synset, but linear dependency too strong for this task, and our experiments show it. And log of 1 plus count show better results. Score patterns is updated score base by some statistics from patterns feature. If we have some synonym hypernym pattern with this word and with this candidate, we multiply our score to 2. If we have some statistic about the pattern, the cohyponym pattern with this word, target word, and this candidate synset, we also try to increase weight of this synthetic. And after that, we multiply pattern score on 1 plus BERT probability. We tried to multiply only on BERT, but this variant showed better results. All parameters was chosen by manually on several experiments without any machine learning. Okay, and as results, let's watch on the nodes firstly. In this task, use two metrics: map, mean average precision, and MRR, mean reciprocal rank. Base means use only of score base and without any patterns or BERT or any special processing of name identity context. Base and year situation when we use special processing of name identity context. And as we can see, and as we see in our experiments, special processing always slightly improve results, but not really much, but always. Also for nodes in a public and private part, patterns improve results to all types of patterns and the combination of patterns too. BERT also improve results, and as we can see, combination of all features made the best configuration in our case for our experiments. But for verbs, it's not so good, because somewhat the patterns only decrease results for a private part of data set but on public part patterns was helpful. We don't know now why, but we will investigate it later. And as we can see, BERT helps for verbs too in both public and private situations. In conclusion, we investigate the influence of several features like the exclusion of context of name entities for nouns, the use of BERT, and two types of two types of patterns. Inclusion of near context slightly improves the results always. In all cases, except for private verbs, patterns significantly improves results too. Using BERT strongly increase the results, improves in all situations. The described approach updates the force result on the known private set, and we don't use any additional vocabulary definitions. We try to extract the maximum information only for provided dataset because it's reflects the real situation when you want to extend your thesaurus on new domain. Thank you. Questions?